Okay, in seeking to understand what this Turing machine does, the first thing we might want to look at is what the input symbols for this language are. And if we look at some of the states here, you can see, for example, state Q0 has transitions on 0 and 1 as inputs. State Q1 has transitions on 0 and 1 as inputs. State Q2 has transitions on 0, 1, and blank as inputs. And so it looks like, if we look at all the states, we're probably limited pretty much to 0, 1, and blank as our input language. Of course, we use blanks to delineate the beginning and end of input, so we're really looking at language that's made up of zeros and ones. Other things we can take note of fairly quickly. Notice that all of the transitions all move to the right after consuming one input symbol. So this is apparently a single pass being made over the input, fairly straightforward. Notice also that where we have an input 1, the output symbol being written is a 1. Where we have an input 0, the output symbol being written is also a 0. Where we have an input symbol of blank, the output symbol is blank. So this particular Turing machine appears to be very simple in the sense that it's not actually rewriting anything on the tape. It's a very pure look at the language, or look at the string and decide to accept it as belonging or not belonging to the language. So that gives us sort of an overall view. Now the next thing I would do is to look at some of the ways to get from the initial state to the accepting states. And we've only got one accepting state here, and that's Q3. So one way to get from there is to go from Q0 to Q1 to Q2 to Q3. And if we look at the simplest input that would take us there, it would be 0, 1, and then a blank. So that suggests that the pattern 0, 1 is in some sense significant here. We can actually try that out. If we just feed this Turing machine and input 0, 1, we see that it starts with its head pointing at 0. We step forward going into Q1. The head is now pointing at 1. We step forward accepting that 1, go into Q2. And now the head is pointing at the blank at the end of the input, which means our next transition, we accept that blank and go to the accepting state Q3. What else can we do around that path, Q0, Q1, Q2, Q3? Well, you can see that from Q2 you're allowed to loop around on ones. So initial ones don't count. But once we see a 0, we move to Q1, and then we're allowed to loop around on some additional zeros. So basically we've got a pattern of one or more zeros are required. Then when we see a 1, we move to Q2, and again we're allowed to loop around on ones, staying in Q2. So we've got a pattern of one or more zeros, followed by one or more ones, and then end of string. So again, we can sort of verify that by trying it out. If we try something like, let's throw in a few ones to begin, and then a couple of zeros, and a couple of ones, we can see that on the initial ones, we stay in Q0. Only when we actually consume a 0 do we move forward into Q1. A second 0 keeps us in Q1. When we see a 1, we move forward into Q2. Any additional ones leave us in Q2, and only when we come to the end of the input and see a blank do we move to the accepting state. So we've got a pattern so far of looking for one or more zeros followed by one or more ones. What about the branch that takes us from Q2 to Q3? We haven't really explored that yet. So if we see zeros followed by ones followed by blanks, we're going to go to the accept state. But if we see zeros followed by ones followed by a 0, we're going to come over to Q4. And in Q4, if we continue to see zeros, well, we're good with that. If we hit the end of the input, we're going to come up to Q3 and accept. If, however, we see a 1, we're going to come down to Q5. So we've just seen, again, that pattern of one or more zeros followed by one or more ones. That key pattern of 0, 1 occurs, but this time we don't accept after a 0, 1. We come down to Q5, and we hang around here on more ones. But if we see yet another 0, we're going to come to Q1, and then if we see another 1, we're going to come here. So this pattern 0, 1 seems to be significant. If you watch what happens, 0, 1, if we're done, we'll accept. Another 0, 1, if we're done, we don't accept. A third 0, 1, if we see that, then if that's the end of our input, we'll accept. If we see a fourth 0, 1, we'll come down here, and even if we're at end of input, we don't accept. If we see a fifth 0, 1, we'll come back here. So this seems to actually be looking for an odd number of occurrences of the pattern 0, 1. And again, we can try testing that out by throwing in something like, let's just try 0, 1, 1, 0, 1. Which has an even number of occurrences of the pattern 0, 1. And not surprising, the first pattern takes us to Q2. That next 0 takes us to Q4, and that one leaves us stranded in Q5, which means that we fail when we try to consume that blank. But if I do 3 0, 1s, I'll step to Q2 on the first 0, 1. The next 0, 1 takes us to Q5. And the third 0, 1 takes us to Q1 and then Q2 again. And now we can accept that final blank. So this seems to confirm the notion that what this Turing machine is accepting is all strings with an odd number of occurrences of the substring 0, 1.